Hello Unite and welcome back to Mathematics. In today's lesson we're continuing with our topic of indices and surds, and what we're doing here is we're continuing from what we looked at last lesson with scientific notation, and we're building off of that to use something called significant figures. So here in our learning intention and success criteria, we want to be able to express numbers using scientific notation and significant figures. What we want to be able to do by the end of this lesson is identify significant figures for numbers and write numbers in scientific notation using significant figures. So let's get started. Now, last lesson we talked about scientific notation, and we said that scientific notation was a way that people, mathematicians and scientists, write very, very, very big numbers and also very, very, very small numbers in a really small and short and concise way. And the way that we did this was by using this particular form, a times 10 to the power m. A was a number between 1 and 10, which told me the measurement that we're looking at in particular, and m was the magnitude. What we're doing today is we're building off of this scientific notation that we looked at last lesson, and in particular, we're changing stuff with this value of a. We're doing things with this value of a. The way that we do this is by using something called significant figures. Significant figures is another way of rounding or telling how specific a measurement is. So here's significant figures. Let's quickly go through a definition of what that is. Significant figures of a number are the digits that contribute to the value of the number. So they're the digits that contribute to the value of the number. The more significant figures a measurement has, the more precise the number is. The first significant figure of a number is the first non-zero digit starting from the left. So significant figures is just a way of measuring or how accurate a measurement is. You could measure something and you could have a ruler that has only, for example, regular ruler has 1 millimeter measurements, and so that actually tells you how accurate your measurement is. However, other rulers might only have every centimeter, and so that's not as accurate, and so significant figures is used to actually indicate how accurate a measurement is. When it's written down though, the way that we can tell what a significant figure is we look at how many important or significant figures we have in our measurement. So for example, here we're going to talk about my height. Now, I am roughly 175 centimeters tall. So if we start from the left, here's a few different measurements that could represent how tall I am. So here, if we start from the left, this measurement here, 170 centimeters, it's close to 175, but so like for example, if someone has a ruler that only measures every 10 centimeters, 170 is actually, based on that ruler, might be an accurate measurement. And so here, this is a measurement which has two significant figures, or I'll actually explain something later, but the way that we read significant figures is we start from the left and we go, okay, let's start and find our first non-zero number, which is 1. So this is my first significant figure. And then I go from there, and then the next number, 7, that is our second significant figure. And then we stop at that 0 for now. Now, I'm going to explain about that in a bit more time in a second. So here, this measurement has two significant figures. Another way that you can think of significant figures is kind of like rounding with decimal places. If you remember with decimal places, when we round, we just basically want to stop it at whatever decimal place we're rounding to. And so what we actually do, that significant figures is kind of like another way of rounding numbers. And so here, if I'm telling my weight correct to two significant figures, I'll be 170 centimeters tall. Actually, that wouldn't be true, actually, now that I think about it. But for this example, that would be the case. Now, the next measurement, I've got 175 centimeters, which is roughly where I am, how tall I am. Now here, if we wanted to count the significant figures, we start from the left and we go to the right. 1 is our first significant figure. 7 is our second significant figure. And we've got this third significant figure of 5. We've included that 5, which gives me a little bit more accuracy in my measurement. The previous one, they measured it as 170. But here, now that we've included that third significant figure, it's telling me that it's a little bit more accurate. So here, this is 3 significant figures. And from there, you could get even more accurate. So let's say someone had a really, really accurate ruler, a really precise ruler, and they could measure it to the 10th of a centimeter. And so here, this third example, well, if I read from left to right, I've got 1, 2, 3, 4 significant figures in this measurement. And so here, I can get even further and closer down into my measurement. And here, next example, we've got 175.720. And so just like that first one, we're not going to count that 0 for now. But here, 1, 2, 3, 4, 4 significant figures. And the last one, well here, I've actually got this 1 at the end as well. So what this tells me is I need to include all of those numbers. So 1, 2, 3, 4, 5. So this is 5 significant figures. So significant figures is just starting from the left, going to the right, how many digits contribute to that value of my of a measurement. Okay, now, just to give you an idea of which digits we actually include, which digits are not significant. So there's a few specific digits, and in particular, this has to deal with zeros, which tell us which aren't significant to my measurement. So leading zeros. If you have zeros at the front of your number, they are not significant. So for example, if I wrote the measurement 17 as 0.17 centimeters, for example, now nobody writes it like that, but if someone did write it like that, this 0 is not a significant figure. It's not important. Zeros at the front without any other digits before it is not an important figure. Similarly, if you've got a really small measurement like 0.000000017, all these zeros here, they're leading zeros. There's zeros before, zeros at the start. And so I can ignore all of these. And so the first significant figure is this 1 over here. So leading zeros are not important. So including that one as well. Leading zeros are not significant figures. Now the other one, I've put the second type of numbers, digits which are not significant, which I've included here and put an asterisk, is trailing zeros. Now the reason why I've put trailing zeros is because when you have numbers at the end, so let's say I have 17,000, those zeros at the end, we can't tell if they're significant or not. So it could be, but also might not be. So this measurement here, there's 1 and the 7, they're definitely significant figures, 1, 2. So we've got 2 significant figures. Let's see if I can learn how to write correctly. Figs. But the zeros at the end, we can't tell if they actually are significant figures. So this could be 2 significant figures, or it could be 2, 5, or 5 significant figures. So when we're trying to tell how many significant figures a number has, we need to just follow these 2 particular rules in just telling me what numbers I ignore, which zeros I ignore. If you've got leading zeros, so zeros at the front of your number, we ignore those zeros. They are not significant figures. And if you've got zeros at the end, they could be significant or they might not be. We can't tell, unfortunately. So let's have a go at an example of a few examples where we need to identify how many significant figures are. So example 1, identifying the number of significant figures. So state the number of significant figures given in these numbers. So what we want to do is we want to figure out how many significant figures there are in the following numbers. So let's have a look at this first one. I've got 451,000. So I'm going to start from left to right. And here, I'm just going to count up how many significant figures I have. So the first number is a 4. That's a significant figure. So here, 4 is one significant figure. 5 is one significant figure, and 1 is another significant figure. So here we have 3 significant figures. But as I said just above, notice here we've got zeros all at the end. We can't tell if they are significant figures or not. So we have to say it's either 3 significant figures or what's it called? Here it's 1, 2, 3 more, so or 6 significant figures. So we don't know where those significant figures stop when they're at the end. And so here we've got either 3 significant figures or 6 significant figures. Okay, that's for this first one. Let's have a look at the next one. 000005012. Okay, so we start from left and we read to the right, and we just consider, okay, if we've got zeros at the end and zeros at the front, we don't consider them insignificant. So let's start here. So here we start off with a 0. It's at the front. It's not significant. Then we've got another 0. There we go. Not significant. Third 0, not significant. The first significant number is this 5. Now, the next number is a 0. Now, here, this 0 is not a leading 0 or a trailing 0. In order for it to be a leading 0 or trailing 0, it needs to be at the end with no other digits either side. So my 5 is my first significant figure, but if you have a look at this 0, after that 0, we've got numbers, like non-zero numbers, so 1 and 2, right after it. So this makes this 0 a significant figure. So that's my second significant figure. Third significant figure is 1, and fourth significant figure is 2. And so here, this has 4 significant figures. Okay, so that's my next example. So here we're just going from left to right and counting up all of my significant figures. Okay, last example. Now this number, if you have a look at this one here, 3.12. Now this is written in scientific notation. The way we read significant figures from scientific notation is we just focus on the measurement part. And this is where we're going to actually be doing this later on when we're writing numbers in scientific notation with significant figures. So we're only going to focus on this part here to look at significant figures. So let's do that. Left to right. 3, that's not 0, so that's my first significant figure. And 2, that's also not 0, and that's my second significant figure. And there's no other numbers after that, so this is just corrected 2 significant figures. So that's how we can identify significant figures. Significant figures, we start from left to right of our number, and we go count how many specific significant figures there are. So we exclude leading zeros. So if there's zeros at the front, just like in this second example, up until that first non-zero number, we ignore those. And if there's trailing zeros, like this first example here, well, we can't be sure. And so we need to say that it's either 3, which is how many non-zero numbers we had before that, or 6, because we can't tell. Okay, so that's identifying the number of significant figures. What we want to also now be able to do is actually write numbers. We want to write numbers in scientific notation using this significant figure stuff. So, writing scientific notation with significant figures. So, numbers can be rounded using significant figures, just like we do with decimal places. So, when they ask you to round something in significant figures, all we need to do is just find that particular significant figure that they want us to use, look at the next digit, and then round up or down, just like we normally would with decimal places. And then we use it for scientific notation. So if you remember from last lesson when we looked at scientific notation, these steps will be fairly familiar to you. So when we're writing numbers in scientific notation with significant figures, what we want to do, find the first significant figure, place a decimal point after that digit, just like we did last lesson. Count how many times the decimal place has moved from the original one. So just like last lesson, if we move our decimal place to the left, to get from our original to our new, that means we have a positive power of 10, and we move it to the right, it means we have a negative power of 10. And this is where it's a little bit different from what we did last lesson. In step 4, from the first significant figure, what we want to do is find the relevant number of significant figures. So they'll tell you they want it correct to, e.g. they might want it to correct to 2 significant figures. And so what we want to do is just find where the second significant figure is. Then we want to then round this digit. So just like we normally would with decimal places, we're just looking at the next number and then rounding up or down. So just to give an idea of these steps, let's have a go at an example. A couple of examples that we have here. Writing numbers in scientific notation. So here we've got 2 numbers, and we want to, firstly, there's two questions here. So write these numbers using scientific notation, and we first want to do it with corrected 2 significant figures, and in the second part, we want to do it corrected 3 significant figures, just to show you how it's different here. So let's go through the first one. 2,183,000. Now we want to write this in scientific notation with significant figures. So what I said was, best way to start off is just to write this in regular scientific notation. So what we do is we go from left to right and we find the first significant figure, which happens to be 2, and we just put a decimal point after it. So here, I'm going to put this decimal point here. So I'm going to write 2.183, and I'll stop at the zeros, times 10 to the power. Now we want to count up how many times we move the original decimal point. The original decimal point was over here, right next to the 0. And so we move it to the left, 1, 2, 3, 4, 5, 6. We move it 6 times. So that tells me that we're multiplying this, and because we're moving to the left, it's going to be 10 to the power 6. So last lesson, that's how we would have written this number using our scientific notation. But in this question, we want to write this using 2 significant figures and then 3 significant figures. So if we want this corrected 2 significant figures, so 2 sig figs, all we do is we look at this decimal part and we go, okay, I just want the first two significant figures. So if I have a look here, first 2 significant figures, the first one is 2 and the second one is 1, and then we just need to round that 1. So I look at the next number after 1, that's an 8, which means I need to round up. And so this becomes 2.2, because that second significant figure has been rounded up, times 10 to the power 6. Notice the power doesn't change at the end. All we're doing is changing that second decimal place and we're rounding at that particular spot. Okay, now example part 3 was we wanted to do this to 3 significant figures. So 3 significant figures, we're going to go to the third significant figure. So here, the first one was 2, the second one was 1. The third significant figure is that 8. And so here we're going to have 2.1 for the first 2 parts. And then from that 8, we just round it. So look at the next number, 3. When I have a 3, I round down. So that means I keep my 8 the same. So this is going to just become 2.18 times 10 to the power 6. Notice once again, this 6 does not change. The power of 10 does not change. Nothing in this power of 10 has changed. All we're doing is rounding it at different spots according to significant figures. Okay, so that's how we did this first example. Let's have a go at the next one. I've got 0.0019482. Okay, let's write this in scientific notation. Scientific notation, we find the first significant figure. So go from left to right. I get rid of all the leading zeros here. So get rid of this 0, get rid of this 0, get rid of this 0. And 1 is my first significant figure, and I just put a decimal point after that. So this is going to be, in scientific notation, this would be 1.9482 times 10 to the power. So this is my scientific notation part. Just regular scientific notation. And then I just want to find how many times I moved from my original decimal point. My original decimal point is here between that 0, the first 0 and the next 0. So I count 1, 2, 3. And because we're moving to the right, it's going to become a -3, 10 to the power -3. So this is my regular scientific notation. What we want to do is now incorporate that significant figure. So the first part was 2 significant figures. If I want to round this to 2 significant figures, all I do is I look at my number. First significant figure was 1. So this is my first significant figure. And my second significant figure is my 9. So here I'm going to write down 1 point. Okay, the 9 I round here. 4. Do I round 4 up or down? Well, when we get a 4, we round it down. So that means I leave that 9 the same. So here I'm going to have 1.9 times, and the final part doesn't change, times 10 to the power -3. So that's correct to 2 significant figures. So if you have a look at this measurement, this has 1, 2 significant figures. 2 significant figures. Okay. Part 3. We want to do, part 2. Sorry, my bad. Part 2, we wanted to do this correct as 3 significant figures. So if I want 3 significant figures, I just need to include that next significant figure. So here, that 4 is the third significant figure. And I look at the next number, 8. Now with 8, I round that up. And so I'm going to need to increase my 4 by 1. So this becomes 1.95 times 10 to the power -3. So that 10 to the power -3 doesn't change. All we have done here is we've included that next significant figure. So if you have a look at my number, I've got 1.95. And so that's 1 significant figure, 2 significant figure, 3 significant figures. So that's how we can write numbers in scientific notation using significant figures. We just write the regular scientific notation that we did from last lesson. And then from there, we look at that number and we just round it using our significant figures. We start from the left and we read to the right and we go, okay, where's my first significant figure, second significant figure, third significant figure? We look at where we need to round off and we just look at the next digit, and that tells me if I need to round up or down. Okay, then that's how we write scientific notation with significant figures. Now the final part is actually we want to do some calculations using scientific notation. So use a calculator to evaluate each of the following, leaving your answers in scientific notation correct to 4 significant figures. Okay, so I'm going to show you how to do this using your regular calculator for the first part. And then in the second part, I'm going to actually show you a way that you can actually cheat this a little bit and make it do this a lot quicker. So let's have a look at this first one. So what we want to do is we want to figure out what this answer is and then write it in scientific notation correct to 4 significant figures. Now for both of these questions, there's actually a button I'm going to use to make things easier. Whenever you see this times 10 to the power 5 times 10 to the power 4 times 10 to the power -3, there's actually a button on your calculator that actually looks like that. It looks a bit like this, times 10 to the power 10x. So this is a button and it's at the bottom of your calculator. So if you have a look at the bottom of this calculator, right next to the answer button, there's actually times 10 to the power x. And so when I press that button, if you have a look, that gives me this power of 10 button section. And so here, for example, if I want to do times 10 to the power 5, I just put a 5 after that, and it makes it a lot easier to type this in. So what we want to do is just put these numbers in our calculator. So here for the first one, I'm just going to go 3.67 times 10 to the power 5 times 23.6 times 10 to the power 4. So here I'm using that times 10 to the power x button, pressing equal. Oh, excellent. They've actually given it to me already in scientific notation. So notice here I've got 8.6612 times 10 to the power 10. So here they have it in times 10 to the power 10. So I want this to 4 significant figures. So if you have a look, I'm going to count from the left. 8 is my first significant figure. 6 is my next significant figure. The next 6 is my third significant figure, and 1 is the fourth significant figure. I look at the next number, 2. Do I round that up or down? I round it down, and so my final answer is going to be 8.661 times 10 to the power 10. Okay, first example done, nice and easy. We just need to chuck this in the calculator. Let's have a look at this next one. Now I'm going to also put this in my calculator, so let's do that. So I've got 7.6 times 10 to the power minus 3 plus square root 2.4 times 10 to the power minus 2. So once again, that times 10 to the power x button, really easy and really helpful for us to actually do this a lot quicker. And so here we get this number, 0.1625, that's the wrong button, 193, whatever. Okay. And we want to write this in scientific notation correct to 4 significant figures. So here, oh, let me include the next significant figure. It's 19. Okay. So using our scientific notation, well, we look at the first non-significant, we look at the first significant figure, we get rid of the 0. The first significant figure is this 1. So I put a decimal point after that. So this becomes 1.62519 and so on times 10 to the power. Well, I figure out how many decimal points I need to move to get to that point. So here, the original one was over here. So we only needed to move it once, and we're moving it to the right. So it becomes to the power minus 1. Okay, we want this correct to 4 significant figures. So I'm going to count from my left to right. So 1, 2, 3, 4. I look at the next number 1. I round that down. And so here, this becomes 1.625 times 10 to the power minus 1. And so there we go. Okay. Now, there is a easier way to do these questions, which involve changing up a setting on your calculator. So if you go to your calculator and press Shift Setup, so Shift on the yellow button on the top left, and then press the Mode button, which also has a Setup feature, you get to the settings of your calculator. Now, on the settings of your calculator, there's actually a button that changes all of your answers to scientific notation. And if you have a look, it's this number 7, Sci. Sci is just short for scientific notation. And so if you want to have all your answers in scientific notation, just by pressing that, you'll actually turn it on into scientific notation mode. So here, if I press 7, they say Sci 0 to 9. If I press any number between 0 to 9, that'll just change it to scientific notation. 0. And if you have a look in the top right, there's this little Sci at the top. And I've actually changed my answer into scientific notation. Look, 1.625 times 10 to the power minus 1, which is what they have here. Now, if you want to get rid of that, the way that you get rid of that, Shift, Setup, and press 8, which is normal. So you change it back into normal mode, 8, and you have to press 1 or 2 to change it back. So I'm pressing 1. It gives it back to me in that original form. Okay, so that's how we deal with scientific notation with significant figures. That last bit was just a little bit of an aside, just in case you wanted to change up your calculator and made it easy for yourself. So that's it for today's lesson. Let's do a quick recap. Today we talked about significant figures, and significant figures are just the digits that contribute to the value of our number. So here we started from left to right, and we read our number to the right, and we started at the first non-zero digit of our number. So when we are counting significant figures, we get rid of any leading zeros, any zeros at the front we ignore, and any trailing zeros we're not actually sure, so we can either include it or exclude it. So that's why we have to give 2 specific answers. When we're writing numbers in scientific notation, all we do is just write our number in scientific notation. Then after that, we round using significant figures. So that's what we did in today's lesson, Year 9. If you have any questions, feel free to send me a comment or ask me a question on Google Classroom. More than happy to answer your questions. But that's it for today. I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye.